Hello and welcome to this session entitled Getting the Most from Modern Java. My name is Simon Ritter and I'm the Deputy CTO at Azul. The idea behind this session is to explain to you a lot about what the changes are that have been made to Java since the last long-term support release. That was JDK 11. We've just had JDK 17 released, and that's the current long-term support release. So there are 6 versions of Java. What I'm going to focus on in this session, because it's only short, is just the changes that have been made to the syntax of the language. So I'm not going to focus on things around new APIs, new libraries, or anything that affects the JVM specifically. So we're just going to be talking about things that have affected the language. So let's get started then. And very logically, we'll go through this in terms of each version of the JDK that's been released, and we'll start with JDK 12. Now, what we got in JDK 12 was a change to the way that we can use switch. In the past, we've had switch statements, and these have been in the language right from the very beginning. They were taken really from the C programming language because that had a big influence on how the Java language initially developed. And what we find with switch statements is that they are very useful in terms of being able to do an effectively a if then else set of conditions. But there are some things that make them a little bit more error prone than we would like them to be. And we can take a couple of examples there. First, most obvious of those is the fact that for each block of case statements, we need to do some action, and then we have to remember to put a break statement in. And it's quite legitimate not to put a break statement in. What that will result in is falling through to the next set of case statements. And there are certain situations where that is useful, but most of the time you don't want that. Most of the time you actually want to do a break and then exit from the case statement at that point. I, as I'm sure many of you have done, have at some point forgotten to put a break statement in, and it introduces bugs which can be a little bit more difficult to find than you might think, because of course you get unexpected behavior and you don't really know quite what's going on. So that's one of the things that's a bit of a drawback with the case statement the way that it was. The other thing is that in terms of local variables, some of the way that we can use those within the case statement can be a little bit counterintuitive. What JDK 12 brings to us is the idea of switch expressions. Now, these are a preview feature. Everything from JDK 12 onwards in terms of language has been introduced as a preview feature. This is one of the advantages that we see in terms of switching to a 6-month release cycle, is that we can introduce features, allow people to try them out, allow people to provide feedback, and then if necessary, make some changes to them before they become final features. Now, important thing about this is not like beta testing. This is not taking sort of not quite complete features and allowing people to test it as they're being developed. Everything that's being introduced is a fully formed feature. There's nothing missing from it. It's just about getting feedback about, are there any things that developers would like to change before it becomes final? So that's the idea of a switch preview feature. One other thing to mention briefly about preview features is that you do have to enable them when you compile your code with the enable preview flag, and you also have to specify which version you want them enabled for. And then when you run your application, you also have to enable preview features. The reason for this is because they're not part of the standard yet. So to enable write once, run anywhere to work still, you have to explicitly say, yes, I do want to enable those features. So switch expressions are now a preview feature. Let's talk a little bit about what that actually means. If we look at a very classic example of how we use a switch statement, this is a very, very common pattern in terms of using this. What we're doing here is we're switching on the day of the week, and we want to assign a value to the number of letters. So we're switching on one variable and assigning a value to another variable based on that. If we look at the code here, obviously I've created a field, an instance field called number of letters or a local variable, and then I'm switching on day, and then for case Monday, case Friday, and case Sunday, I set the number of letters to be 6, and then I have to break from the switch statement at that point. Clearly, for each of the different cases, I have the same style of code. Obviously, The problem, as I said, is if we forget to put a break statement in, then we'll drop through and things won't work the way we expect them to. Also, we can have a bit of an issue because if we're using an instance field, then if we forget to assign a value to number of letters, that will still compile, but we'll get a value of 0. And again, introduces a sort of subtle bug. If we're using a local variable, the compiler will catch that. But if we're using an instance field that we want to assign the value to, then we can still get some subtle bugs creeping through there. Obviously, the other thing that we can see here is there's a lot of code. There's lots of lines of code in order to do what is a fairly simple task. This is the switch statement. In terms of what we get with JDK 12, as I say, this is a switch expression. Now, the difference between a statement and an expression is that the statement executes some instructions, but doesn't return a result. A switch expression, or a general expression, executes some code and then generates a result that we can assign to a value or a variable if we want to. Now, we can see here that the code immediately looks a lot smaller. What we're doing is we're saying, okay, we have a switch expression. The expression returns a result, which means that we can assign the value of that to number of letters. We only do that once, so it eliminates the problem potentially of the error creeping through because we forget to set a value returned from the switch when setting it in the switch statement. Here, what we can see now is we switch on day, and then we've got case Monday, Friday, Sunday. This in itself is a massive change. I find it very difficult to believe that it's taken us 25 years to figure out that we could put the variables or the values that we want to switch on a comma separated list rather than having case Monday, case Friday, case Sunday. Okay, well, anyway, but that's really good. And then what we've done is we've borrowed some of the syntax from Lambda expressions. So we use the arrow operator. On the right-hand side of the arrow operator is what we're going to return from the switch expression for Monday, Friday, Sunday at 6, Tuesday at 7, and so on. And if we need to, in the default case, we can throw a new exception and deal with that particular situation. What we see here, as I said, is a lot less code than we had before. But the really important thing about this is much more concise, but without losing any of the readability that we have in the previous code. So we can see exactly what's going on. We can see all of the different aspects of this code, nice and small, easy to read, easy to see what's going on. So this is a really, really good feature, I think. Now, what we can do is we can combine the old style syntax with the new style switch expression if we wanted to. In this case, again, we're assigning the value from the switch expression. We're separating out our cases, so case Monday, case Friday, case Sunday. But this time, rather than using the arrow operator, we need to indicate what value is going to be returned. And the developers in this case decided to overload the break statement a little bit more. At the moment, prior to JDK 12, the break statement can be used in two ways. Firstly, it can be used to break from a switch statement, but it can also be used if you're in a loop and you can break out of a loop to a label. They decided to extend that and say, okay, if we're in a switch expression, we'll use break because that's what you would use in a switch statement, but we'll just add a value after that, and that's what's going to be returned from the expression. Okay, we'll come back to that in a minute and discuss how that's, maybe other ways of doing that. Obviously, because a label can't start with a number, the compiler can resolve whether we're breaking to return a value or breaking out of a loop potentially that we could be in and breaking to a label. Moving on to JDK 13. So 6 months later, some more development of the core platform. What did we get in JDK 13? Well, another preview feature. As I said, all language features from JDK 12 onwards are initially introduced as previews. In this case, we're getting text blocks. Now, in Java, right from the very beginning, we've had the idea of strings, and we've had the idea of strings of characters that we can use. We can create string literals simply by indicating it with a double quote at the beginning and a double quote at the end. The drawback, if you like, or the limitation on that is that in terms of creating strings that contain special characters, or especially strings that want to have new lines in them, it's not easy to do that. You can't simply create a string with a new line and then expect that to be included. The compiler won't like that, and you need to do it through either concatenation or escape characters or things like that. So for string literals that are multi-line, Java hasn't really been very easy to do that. In JDK 13, we get text blocks. Now, the way this works is we can see here, we create a string, and rather than using a double quote, single double quote, to indicate the start and the end of the literal, we use 3 double quotes. We borrowed some of the syntax from Python, does it in the same way. So we use 3 double quotes to indicate the start of our text block, and then everything after that is going to be treated as part of the string, whether it's special characters, whether it's new lines, doesn't matter, up to the next 3 double quotes, closing 3 double quotes. Obviously, if we wanted to include 3 double quotes into our string, quite legitimately, then we can do that by escaping, by putting a backslash in front of at least the first of those 3 double quotes. So if you do that, you can include that into the string. Otherwise, the second set of 3 double quotes will terminate the text block. We can see here we've got some HTML tags, and then we're going to print them out. So let's see what that actually prints out. Okay, prints out what we would expect in terms of our HTML tags. But it might not immediately be obvious from looking at the way that it's laid out above that the results would be what we see below. What do I mean by that? Well, obviously, we need indentation for our tags. We've got the opening and closing HTML tag, we've got an opening and closing body tag, and a paragraph tag, all of which need to be indented by a couple of spaces. But if we wanted to do that, you could think that in order to have all of the opening and closing HTML tags aligned with the left-hand margin, you would then have to move the text block over so it was on the left-hand margin as well. That's not really good for layout of source code, because we want to be able to have it more readable. And as we see above, we want to push them over to the right-hand side so it lines up with the rest of the source code, and we can see where the variable is and things like that. So how does that work? Well, what text blocks does is introduce the idea of intentional white space. Intentional white space is essentially any white space to the left of the first character in terms of the columns. So as you can see from the arrows there, all of that white space up to the start of the HTML tag is incidental white space, and that will be stripped out. It means that we can lay out our code, move things over to the right so it's more readable, but not worry about losing all of the spaces to the left-hand side. We certainly want some space for the indentation of our tags, but we don't want all of it, because otherwise we push it over to the right-hand side. So that solves the problem of keeping our intentional indentation versus the source code layout. Second thing to be aware of is that the 3 double quotes that you use for the opening of your text block also has to be followed immediately by a new line. You couldn't put the initial HTML tag directly after those 3 double quotes. It has to go on a new line. And the last thing to be aware of, which is a little bit odd, I'm not quite sure why they did this, is that if you put trailing spaces after the text on your lines of your text block, then those will be stripped out. So I added 4 extra spaces after the closing HTML tag, and if we printed out if we could see what was actually being printed out there, you would find that those trailing spaces had been stripped out. Now, what we could also do is decide that we actually want to introduce some more padding for our text. Now, we can do that by shifting the closing 3 double quotes from immediately after the closing HTML tag onto the next line and moving it across to the left. Because what that does is introduce intentional additional indentation, as well as some intentional white space. So we've got a combination of the white space that we need for the layout, and we've got white space that we want to include to move our tags over to the right-hand side. If again, we print out what the results of that are, then we'll see that now our tags still indented in the way we want them to be, but all of them are shifted over by 4 spaces, which is what I've included as intentional indentation. The only downside of this is that because we've moved the 3 double quotes onto the next line in order to indicate our intentional indentation, we get an extra new line into the text block. So we get an additional blank line, which might not be what we want. I will come back to that in a moment. Switch expressions. I've already talked about switch expressions. So why am I talking about switch expressions again? Well, this is a perfect example of how preview features works really well. As I said, you can combine the old style syntax of switch statements with a switch expression. And the idea was you would use break with a value to indicate what you wanted to return from the switch expression. People looked at that and developers said, well, we don't really like that, because even though the compiler can determine which thing we're actually doing there, it's a bit kind of confusing and it might be harder to understand what's happening with the code. So the developers of that feature looked at it and they said, yep, you know what, you're right. So we will change how that works. And they could do that because it wasn't a final feature. They changed how that worked and they said, rather than using break, we'll use yield instead. That way there's no ambiguity in terms of, are we breaking to a label? Are we breaking out of a loop? No, we yield a result from the switch expression and then we know exactly what's going on. So nice idea of just making a small change to the feature before it became final. Moving on, JDK 14. JDK 14 for me was a very good release. It had several interesting features in it and things that really help developers. First of those relates to data classes in Java. Now, we do this a lot because we have an object-oriented language. What we want to do is to encapsulate some simple values. It might be that we want to return more than one thing from a particular method, and to do that, we put more than one value into an object, into a class, and then we can return that reference rather than a single value. Here I've got a very simple example of that. I've got a point which contains 2 values, x and y, both of which are doubles. Fine. If I look at the code for this, clearly what I do is I create myself a new class. Then I have to define instance fields, x and y, define them as doubles. Then I need a constructor, which takes 2 parameters, double x and double y. It then has to explicitly assign the value of x to the instance field of x, y to the instance field of y. I need accessor methods so I can get the values of x and the value of y. So that's 14 lines of code simply to create what is in effect a tuple. And it would have been good from early days if they had included the idea of a tuple into the class libraries. If you talk to people like Brian Gertz, he would say, well, yes, we could have put a tuple into the class libraries, but then we'd need a triple, we'd need a quadruple, we'd need a 5, 6. How many do you actually want to use and how many, where do you stop? Which is a valid comment. To get around this, in JDK 14, we take a different approach and we introduce another preview feature, which is called records. Records are essentially data classes for Java in a way that makes it much simpler for us to specify them without all of that boilerplate code we saw on the previous slide. If I want to do exactly the same thing that I had on that previous slide, create a class which can contain 2 values, x and y as doubles. Now I simply say, create me a record called point, and then I'll use the brackets and the same syntax as if it was a constructor to indicate that the values stored in that record are going to be double x and double y. All of that extra boilerplate code is created by the compiler for me, so I don't have to do that. Now, it's important to understand that a record is just a slightly special form of a class. It's just another class. The compiler in this case is generating lots of the code for us, but there are a few things that we need to be aware of. So, okay, it's a special class, and if we wanted to, we could add a body to it, we could add more code to it, which I'll talk about in a moment. Second thing, because it is just a slightly special form of class, we can make it generic. So we could have a record, and in this case, I'm calling it anything, it has a generic type parameter t, so I can say I want to store something of type t in that record. Make it generic, all works. So that's quite useful. The other thing is that because it is a special form of class, we can add more functionality to it. Now, we can't add any instance fields above the ones that are defined in the record definition. In this example here, I've got a record called circle. I define that that is going to hold a value, which is a double, called radius. Now, in the body, I can't then add some additional instance fields. So I couldn't have like a diameter, for example, or something like that. But what I can do is add static fields, because those are shared across all instances of the record, and that will work. So there's no problem with that. Here, what I've done is create a static instance field called pi 3.142. And then I've added another method, which is going to enable me to calculate the area of the circle. So I'm using my instance field radius. I'm using the static field to then calculate that as pi r squared. Some other things to be aware of in terms of records and how they work. So as I said, they are a slightly special form of class. And one of those qualities, if you like, is that all records inherit directly from java.lang.record. What that means is when you define your record, you can't say that that record subclass is something else, even if you wanted to, because it already inherits from record. So with single inheritance in Java, you can't then inherit from something else. However, because it's a class, we can implement as many interfaces as we want, and we can provide the implementations of the methods in those interfaces. So you can do that if you want to. It is a class, so if we wanted to, we could override the equals, the hash code, or the toString methods. Those are provided for us by default, but if we wanted our own implementation of that, we can just add those to the body of the record. Records are implicitly final, which means that not only can you not inherit from another class, because we already inherit from record, you can't then extend it further. It's implicitly final. If you really want to, you could add the final modifier to the record, but it's not necessary. Records don't follow the bean pattern. And this is quite an interesting thing, you see, because the bean pattern says that the accessor methods that you use have get followed by the name of the variable. So it would be get x or get y. In the case of records, they decided not to go down that route. And so they used only the name of the variable as the accessor method, x and y. That did cause not problems as such, but it meant that things like Spring as a framework, when people started trying to use records with that in JDK 14, there were some issues because the Spring framework expected the bean pattern. They've subsequently modified Spring so it will work with records. There's no issue with that. However, as somebody did point out to me, you can actually get around that problem. I don't recommend it if you call your variables get x and get y, because then clearly the accessor method will be called get x and get y. It's just a little aside there. Constructors for records. What we can do here is we can add some additional logic if we need to. And so we can end up with something like this. We can use the canonical constructor, which is essentially the default constructor that you get with the class. So here I've got a record called T-Rex, two values, int x and int y. If I want to add some logic to the constructor, in this case to test if x is less than y, I can do that by adding the canonical constructor. But this is not really ideal because now we're starting to add in more of that boilerplate code that we really wanted to get rid of. So we have to specify the constructor. We have to say that it takes two variables, x and y, even though on the line above, we know it's going to take two variables, x and y. We do add a little bit of extra logic, and then we have to explicitly put the assignments of x and y to the instance fields x and y. To get around that, the developers also added the idea of a compact constructor, which then allows you to add logic, but eliminate the need for a lot of that boilerplate code. Now what we can do in the case of our record called range, which takes two values low and high, again, we want to do a test. So we're testing to see if low is greater than high, but by using the compact constructor, which doesn't follow the signature, if you like, of the standard constructor, because it doesn't have the brackets with the parameters, the compiler will know, oh, okay, that's a compact constructor, fill it in for us. And again, we don't have to explicitly assign the values to the instance fields. The compiler will do that for us. So it's sort of take away that extra boilerplate code, make our life simpler, but still allow us to add this extra logic to the way that the constructor works. One thing to be aware of is that there isn't, with the compact constructor, any way of specifying a checked exception. So you can't do public range throws my exception. You can only throw an unchecked exception from the compact constructor. Instance of, another thing that we see a change with in terms of JDK 14. So what we do with instance of is, because we have an object-oriented language, we can view things as different types, polymorphism in action. We may be given a reference to something of a more generic type, and then we want to determine its specific type. So we use instance of to do that. It's a test. Here's a very simple example. We say if obj instance of string, and if it is, then we want to use it as a string. First thing we have to do to use it as a string is create a new variable called string s, and then assign to that the reference obj and do an explicit cast to type of string, which, if you think about it, is just redundant code. I mean, if you want to use the variable in that true branch of the if statement, then every time you're going to have to do that line, and really there must be an easier way of doing it, which there is. What we have in JDK 14 is pattern matching for instance of. Yet again, preview feature. Now, pattern matching as a construct for programming languages has been around since the 1960s. What we're doing here is using pattern matching for types, specifically in the case of instance of. And the way that works is by saying, if obj is an instance of string, but then we'll add a type variable that we can use to reference that obj as a string. So we just put s at the end, and then the compiler, again, effectively adds in the line which says assign to s the value of obj cast as a string. So then in the true branch, we can use s because the scope is valid. It is a string. We can call methods on it, and it will work quite happily. In the false branch, because we don't have a string, the scope of s is not valid, so we couldn't use s and try and reference it as a string. We could be a little bit more clever. We can add what's called a guard, and we could say if obj instance of string s and s.length is greater than 0. Now we know that the way that the AND operator works means that we will always evaluate the left-hand side, and only if it evaluates to true will we evaluate the right-hand side, which means that we know that if the left-hand side evaluates to true, obj is a string, therefore the scope of s is valid. And then when we evaluate the right-hand side, we can call the method on s for length, test it against 0, and that will all work. If we would try and use OR, that wouldn't work. Again, we know that if we execute that code, we will always evaluate the left-hand side of the operator, but only if that equates to false will we evaluate the right-hand side of the operator, at which point we don't have a string, and therefore we don't have valid scope for s, and we can't call length on that, and it won't work. The compiler will reject that straight away. Sometimes you have to be a little bit careful with the scoping of the variables. And so what we could do here is we can actually say if not O instance of string, and I can see I've left out a bracket there, there should be an extra bracket in there. If not O instance of type string, then return from that method, which means that after that, we're actually dealing with the true branch of that if statement in effect, meaning that the scope of S is valid, and therefore we can use that wherever we want up until the end of the method. So that's what's called flow scoping. Next thing to talk about in JDK 14 was text blocks, which again, we talked about that in JDK 13, and this is another example of how preview features are very good, because now we have a second preview where they introduced two new escape sequences. First of those is the idea of a continuation onto the next line. We can use a backslash at the end of our line, and that will then not put a line break in between those two things. That solves the first problem we saw, which is if we want to introduce some intentional indentation, then we need to, by using a backslash, we can avoid that extra blank line. Second thing that was introduced was to address that idea of stripping out the trailing white spaces by adding a backslash s so that you can indicate you do want those spaces to be included in your text block. Again, I'm not quite sure why they had to do that, but that's the way it works. JDK 15, moving on another 6 months. Now, Java, as I said, is an object-oriented language. We have the idea of type hierarchies, inheritance. Here I've got a very simple hierarchy. I've got shape and then 3 subclasses, triangle, square, and pentagon. The problem we have is that we don't have any control over who can inherit from a particular class. If shape is not final, meaning nobody can inherit from it, then anybody can. And that could lead to problems if somebody in a project starts using your class and inheriting from it, and they don't realize that you make changes to it, and suddenly their code changes in the way that it works. In JDK 15, we now have the idea of sealed classes. And sealed classes, another preview feature, is about how you can specify who can inherit from a particular class. You can think of final as being the ultimate sealed class. The other thing to bear in mind about this is that although it's called sealed classes, it also applies to interfaces. I thought it should have been called sealed types, but then I learned something new, which is that interfaces are still technically classes. So they called it sealed classes. How does this work? Well, the first thing you need to be aware of is that all the classes involved in a sealed class must be located fairly locally. So they've either got to be in the same package or the same module. What you can then do is add a modifier to your class, and you can say sealed class. So we have public sealed class shape, and we add a permits clause to that class definition. So now we can permit 3 classes, triangle, square, and pentagon. Our type hierarchy will work. The compiler will be quite happy with that. If somebody were to come along and say, I like that shape class, I would like to subclass it and add a circle. That won't work. The compiler will reject it, generate an error because circle is not specified in the permits clause, so it's not part of that sealed class. Now, the important thing for all of the subclasses of a sealed class is that they must explicitly state the inheritance capabilities that they have. There are 3 ways of doing that, so let's look at what we mean by that. First of those is that we can continue to have a sealed class. We have our triangle, which is a subclass of shape, and we then want to also make that sealed. So a sealed class triangle, add the permits clause and say that equilateral and isosceles are classes that can then inherit from triangle, which then inherit from shape. We could, if we wanted to, the second way of doing our inheritance capabilities is to specify that we don't want any further subclassing. So we will make it final, add the final modifier. In the case of square, then that can't be subclassed any further. And the third one, which is a little bit interesting, is the idea of unsealing the class. So in the case of our pentagon, what we want to do is say, okay, anybody can now subclass pentagon. We don't have any issues in terms of that. To do that, we now use a new modifier, non-sealed. So this is the first hyphenated keyword in Java. So it's a restricted keyword, so you don't need to worry about it being not being able to use it as a variable name. It's only a keyword when it's used in this context. So we have public non-sealed class pentagon, meaning anybody can then inherit from that. Records, they went through another preview. So this was more about adding some extra functionality to it. And one of the things they did was they said, let's allow local records. I think this is very powerful because it means that if you want to use a record just in a particular method, then you can do it like this. So I've got a method called find top sellers, takes a list of sellers, and I want to find out who sold the most in a month and order them in a list. So I can use a local record called sales that contains 2 things, a tuple. It's got the seller and a value of how much they sold in a particular time. Then I can simplify my code considerably by taking the stream from the seller's list, mapping that from the seller to a stream of local sales records, using that seller and a method to calculate how much they sold in that month, pass that through sorted. So I end up with a sorted stream of local sales records ordered by how much they sold in that month. Pass that through map again to map from the local sales records back to the sellers in those records, just simply extracting it, collect that into a list and return it. So it simplifies my code really nicely. I think this is a very powerful feature. JDK 16. So JDK 16 didn't actually introduce any new language features. All it did was finalize a couple of things. First of those was to say that records was now final. So you don't need to enable preview features. You can just use it as you want to in your code. Other thing was that pattern matching instance of, that also became a final feature, although they did make two minor changes to that. First of them was that they said that pattern variables, like the S in our example, are no longer explicitly final. That was one of the limitations in the earlier version of that. The second thing they said was it's a compile time error to compare an expression of type S against a pattern of type T, where S is a subtype of T. I have to read that a couple of times to understand what it means. But if I show you an example, what I've got here is a method that takes a rectangle as a parameter, and then I have a test. I say if our instance of rectangle rec, then print out what the rectangle is. Obviously, I'm passing a rectangle in, so this is a redundant test. It's always going to be a rectangle, so why am I doing this? And the compiler will reject that now. It will say, no, sorry, rectangle is a subtype of rectangle, which it is, so you can't do that. JDK 17, bringing us right up to date. What we get here is more pattern matching. So now we've extended beyond instance of into switch. The limitation with switch before was that we could only switch on an integral value, a string, or an enumeration. Now we can also switch on a type. And here's an example. So I switch on object O, and I've then got certain cases for that. First thing is I have a case for null, which I might want to be able to catch that separately and deal with it. So I can do that. Then I've got a case for string, and I add the type variable S. So if I want to refer to that on the right-hand side of the arrow operator, I can use that and print out what the value of the string is. Or if I've got a color, then I can print out and call the method get RGB to print out the values of that. Now we can't have a case for a primitive because that's not a type reference in Java. But if we have an array of primitives, that is a type in Java. So we can do a case on, for example, int array, and then we can print out the length of the array. One thing to be aware of with pattern matching for switch is that you need to have a complete switch. What I mean by that is, let's take this example here, where I'm passing an object reference, and then I'm only having cases for either string or integer. The problem that we face there is what happens if I pass something that isn't a string or an integer? Well, I could just ignore it and just move on, but that's really losing the benefit of this. So now what you have to do is you have to specify all possible situations in order to have a complete switch. So what I can do here is just add a default statement and say, okay, it's something other than a string or an integer. That doesn't mean we have to have a default statement, because if I take the example I had before of my shape with the Seaward class, then in this case I can say, okay, I've got a triangle, I've got a square, I've got a pentagon, and a shape, because that's the superclass and it is possible to instantiate that. Then I've got all possible types covered if I pass in a shape. Therefore, I don't need a default. We saw the idea of a guarded pattern with instance of, and we can also use that in the switch type pattern. So we can say, in this case, I've got case triangle T, and then do an and test to see whether the area of the triangle is greater than 25. If it is, I'll print out it's a big triangle. If that fails, I might still have a triangle. So I must have a case for triangle on its own. Then I print out it's a big triangle, or a small triangle, and then I've clearly got the other three cases as well. Just to summarize then, one thing to mention that we do at Azul is we can provide you with builds of OpenJDK with all these great features in them. So you can get JDK 17 from us. We provide support for old versions all the way back to JDK 6. You can get builds for Windows, 64-bit Mac, Linux, Windows, 32-bit versions for Windows and Linux, and so on. And it's a drop-in replacement for other JDKs. Conclusions then are, I think the 6-month release cycle is working really well. What we're seeing is lots of new small language features coming in much more quickly than we've seen before. Lots of interesting things, as you've seen during the presentation, that make developers' lives easier, and a lot that I haven't been able to cover that affects libraries and also affects the JVM. One thing that is worth mentioning is that now there are a lot more choices in terms of your OpenJDK distribution. There's lots of people providing different builds of OpenJDK. Obviously, Azul is one of those, and we provide Zulu, which is free. And so with that, I would like to say thank you very much for listening.